As we move to working with equations and inequalities with two variables, we will need to somehow make use of two number lines simultaneously to capture the values for each of the two variables, respectively. The way we do this is with what we call the Cartesian coordinate system, or the rectangular coordinate system. In the graph that we have for this example, the graph has already been set up. Typically, you will be given a blank graph and will need to give it the proper structure, but we will go over that in a few minutes. We'll take a few moments now to quickly introduce some of the key features of the Cartesian coordinate system. The basis for the entire system is the fact that it has two number lines. You have one moving horizontally through your graph, with a scale like any other number line would have, and separately, you have one moving vertically through the graph. Again, the vertical one also has a scale. You should also notice that next to the horizontal number line is a letter x, and against the vertical number line is a letter y. This denotes that the horizontal number line, which we refer to as the horizontal axis, corresponds to the values for the x variable, while the vertical number line, which we will again refer to as the vertical axis, corresponds to the values of y. A more common way to refer to the horizontal axis is that it is the x-axis. This is only true when the variable being used is x, but in so many of the examples we do, and so many of the equations we do rely on x and y, so this does often become the x-axis. And similarly, the vertical axis is called the y-axis. Should we be using an equation that makes use of other variables, then the names of the axes themselves would change to correspond to the appropriate variables being used in the equation. Besides the details related to the axes, you might also notice that the axes themselves split the graph into four pieces. We call these four pieces the quadrants of the graph. Starting with the top right portion, we call that quadrant 1. That is the first quadrant on the rectangular coordinate system. The other quadrants are numbered counterclockwise from quadrant 1, so quadrant 2 is the top left quadrant. Quadrant 3 is the bottom left quadrant, and quadrant 4 is the bottom right quadrant. And one other important feature is where the two number lines happen to intersect. They both intersect at the value of 0 on either number line. This point of intersection is called the origin. It's often thought of as the center of the graph. It is true, though, when you make graphs, that the origin does not actually literally have to be centered at the center of your graph. Depending on your situation, you might want to place it up, down, left, or right from the very center of the graph. In most of the graphing that we will do, we will not actually want to label all of these things with those names. Knowing the quadrants, knowing what the origin is something that will be important when people refer to them, but putting them on every graph usually clutters up the graph so that the key information you actually need is not as visible. So more often than not, the graphs will look like what we started with. You'll have the axes drawn, you'll have them scaled, you'll have their labels, and other details like that, but you don't typically label the quadrants or the origin. This particular coordinate system allows us to plot solutions to equations with two variables in a very precise way. If we have the equation y equals 4x minus 7, I know that the ordered pair 3, 5 is a solution for this particular equation. I know this because if I substitute 3 for the x and 5 for the y, I will obtain a true statement, that 5 equals 5. It's important to remember that ordered pairs are always written in the form x, y. The way we use the coordinate system to plot the ordered pair 3, 5 is to start at the origin and to move to the x value of 3, which is right 3 units, and then move to the y value of 5, which is up 5 units. This gives us the point at the ordered pair 3, 5. We'll then refer to this as the point 3, 5 in this coordinate system. It is critical, though, that we remember the order of the ordered pairs is important. The point 3, 5 is a very different point than the point 5, 3. 5, 3 is referring to an x value of 5 and a y value of 3. Besides not being a solution for the equation y equals 4x minus 7, if we plot this point out, start again at the origin, now go to an x value of 5, so right 5, and to a y value of 3, so up 3, we obtain a completely different point. So the order that we write our coordinates and the order that we refer to these ordered pairs in is critical. It will always be the case that the first coordinate relates to the horizontal axis and the second coordinate relates to the vertical axis. They'll always be in the order horizontal, vertical. Some other vocabulary we should become familiar with. When we refer to the point 3, 5, we will refer to the 3 as the x-coordinate, or the horizontal coordinate. We call it that because it's the value, it's the number that relates to position with respect to the horizontal axis, or the x-axis. Similarly, the 5 is called the y-coordinate or the vertical coordinate because it relates to position with respect to the vertical axis. Again, there will be times where the names of the axes change, where this might not be the x-axis and the y-axis, but the t-axis and the v-axis. Even if the names of the axes change, the structure of the system does not. The ordered pairs will always be in the order horizontal coordinate, vertical coordinate.